Hello, my name is Cameron Castillo. I'm going to be I'm going to be showing off my Engineering 267 project here. So I did the basic MATLAB project with the projectile motion function, and essentially, I the only thing different I did was added a GUI and added drag forces here. So this is a numerical solver. Basically, instead of going through and analytically solving for the max distance and the max height and the coordinates of the max height, I went and solved. I would do a set of iterations on kinematics equations with drag because those are difficult to solve analytically for the max distance and the max height and everything like that, especially with changing parameters, like you change your position, initial starting position, and all that. So what I did was I numerically solved it using by setting up a set of kinematics equations that basically go through and for each time step add on a set of or a new x and y coordinate and update the x and y velocities. So that's done here in this for loop. You can kind of see the kinematics equations that are set up. I won't go into that, but basically that's how I did it. And then you go through and after a number of iterations of that, go through, see where it gets below zero, and wherever it goes below zero, stop it and find the last index, and then solve for what that or find what that is in x position, y position, or however I can do this. So at first I was just plotting it here in the function when I was doing testing on it, but I actually went and made a GUI with this. So let me go over to the app designer. So basically it just takes all of the inputs from the function, right? And then outputs a plot of the projectile position in x and y coordinates, as well as the x and y velocities and a set of output variables. So we go ahead and run this. What we'll see is that we can put in a set of parameters. So here we go, 45. I'll make this really simple for this first one. We'll go with 10,000 iterations here. That makes the thing work for the different drag things we're going to do. We'll give it an initial velocity of 1 meter per second and a mass of 1 kilogram. Now, if we plot this, we'll notice that, well, we didn't add any drag, so this should look exactly like a parabola, which it does. We can also notice that our Vx versus time is a constant, right? So that makes sense because there's no forces acting in the x direction that should slow down the projectile. We also notice that our y velocity is changing linearly. And I'm sure if we actually went and measured this, it would be at negative 9.8, where the slope, measured the slope of that change in the y velocity, we'd be at negative 9.81 meters per second squared, right? Because that's the acceleration that we should be feeling on this projectile. So the only other thing we're going to add to this is if we add some drag to the to this function here, we notice that our parabola now gets skewed a little bit. So you can see here that at the beginning it becomes a little more skewed this way. We can also skew it more if we increase the initial velocity to 10. And we notice, yeah, now the parabola is completely like screwed up in these terms. But that's how it would look in a real situation. So then we can go down to changing the initial angle, plot that. We can change the initial position in the x and y. So if we change it to 1, we can see that it goes to the 1. Or if we change it in the y, we can see that it goes y. It's a little skewed here just because of the way this graph looks in this GUI. But other than that, it basically, instead of solving for this analytically, which is a really difficult problem to solve with all these parameters, we've solved it numerically, and we can see what the max height, the max distance, or sorry, the distance that the max height occurs, seen on this red line here, and the max distance, right? And these plots of Vx and Vy versus time kind of illustrate how the velocity changes and what velocity looks like when you add drag in. So they end up as these sort of sloping downwards functions instead of a constant or a linearly decreasing function. So that was pretty much all I had to say on the project, and thank you.